Okay, so we've already solved some exponential equations. Our goal when we were faced with an exponential equation was to isolate the exponential expression and then write the two sides of the equation so they had the same base. So let's try and do that with example A here. We've got 3 times 2 to the x is equal to 42. Now, you are not allowed to multiply the 3 and the 2 because the 2 has an exponent. Exponents come before multiplication in our order of operations. So our only choice is to divide both sides by 3. So we get 2 to the x is equal to 42 divided by 3 is 14. Okay? Now, our next goal was, can we write 14 so that it has a base of 2? Can we do that? No. We cannot write 14 so that it has a base of 2. 14 is not a power of 2. So our option now that we know logarithms is we can write this in logarithmic form. Okay, we're going to write this in logarithmic form because that's the only way we're going to get the variable out of the exponent. So in log form, this is going to be log base 2. The base of the exponential and the base of the logarithm always have the same base. And the 14 and the x kind of switch places here. So the 14 comes over here, and the x is on the other side. Now, this is the exact answer. Okay, this is the exact answer. If it asks for an approximate answer, you have to use change of base. You have to use log of 14 divided by log of 2 in your calculator to get that this is approximately, don't need that. Nope, not the natural log. Common log of 14 divided by the log of 2. It's approximately 3.807. Is that answer? And you can check it. After you do that, it's an equation. Check it. Plug it back into the original. So we've got 3 parentheses 2 to the answer, second negative. Okay, and that should give us 42. And it does. Okay. All right, let's do B. E to the x plus 5 is equal to 60. We've got to isolate the exponential. So we need to subtract 5 from both sides. So we get e to the x is equal to 55. I don't know about you, but I don't know how to write anything so that it has a base of e. So we're going to write this in logarithmic form. If the base is e, then we use the natural log. It always has a base of e. So this is the natural log of 55 is equal to x. Now the good thing about if our equation is the natural log, then we just type it into the calculator. We don't have to do change base or anything like that. So the exact answer is the log of 55. The approximate answer is 4.007. Again, we can check it. E to the answer, close the parentheses, plus 5, 60. Okay. Let's do one that's got a little bit more stuff going on here. 2 times 3 to the 2t minus 5 minus 4 is equal to 11. Where should we start? Add 4. It's just like we're solving any other equation. You start with adding and subtracting, then you move on to multiplying and dividing. You do realize that when you solve an equation, you go backwards through the order of operations. Has that occurred to anyone? Okay, so then we divide both sides by 2. So we get 3 to the 2t minus 5 is equal to 15 over 2. What do we do now? Log form. So log base 3 of 15 over 2 is equal to 2t minus 5. The whole purpose of putting it in logarithmic form is so that the variable is no longer in the exponent. The variable is now in a place where in the previous two problems it was just by itself. Here we've still got a little work to do. Okay, we need to add the 5. Now, once you have a logarithm, you are not allowed to change anything that's inside the logarithm. Okay, so that plus 5 just gets tacked on to the end. I put a set of parentheses there just so that it's clear that 15 over 2 is the only thing inside of my logarithm. And that's equal to 2t, so then to solve for t, we've got to divide the entire equation by 2. So here is, instead of rewriting it all over again, I'm just going to box it, okay? That is the exact answer for t. Okay, that is the exact answer for t. If we wanted to find the approximate answer, you'd kind of have to do it in pieces. Okay, you start with the logarithm. Log of 15 over 2 using the change of base divided by the log of 3. Okay, that's the log part. Then we add 5 to it. And then we divide it by 2. So it's approximately 3.417. And we can check that. I know it takes time, but I always check my answers, and I try and check them in front of you guys to try and get y'all in the habit of checking your answers so you can find some of your careless mistakes. So plug it back in, we get 11, we're good. Okay, so try these couple of practice problems.